is sales for a business were $3 million more the second year than the first, and sales for the third year were double the sales for the second year. If sales for the third year were $38 million, what were sales in millions of dollars for the first year? So this is a lot of words, so let's go through first and break it down. So that means our first, so let's say let's call the first year sales X. And then if we sold $3 million more the second year, let's call this second year X plus 3. And let's call the third year, since we doubled the sales of the second year, 2X plus 3. So just to recap, X is going to be what we sold the first year, and then we sold X plus 3 the second year because we sold $3 million more the second year than the first. So we need to add those $3 million more back to our X. And then the third year, we doubled the sales for the second year. So we would put a 2 outside the X plus 3 to double those sales. And we know that the sales for the third year are going to be $38 million. So we can set this 2X plus 3 equal to 38. And now we can solve this equation. So the first thing I would do is distribute. So 2x, so 2 times x gives us 2x. And then 2 times 3 would give us 6. And then still set equal to 38. So I would subtract 6 from both sides. And then get 32 equals 2x. And then divide by 2. Divide the whole thing by 2. And that'll give us x equals 16, which would be A. Is in the figure below, ray EF, which is going to be this, was constructed starting from rays ED and EG. By using a compass, D and G were marked equidistant from E. So that means that, we're marked equidistant from E on rays ED and EG. The compass was then used to locate a point F distinct from E so that F is equidistant from D and G. For all constructions defined by the above steps, the measures of DEF and GEF are all of these. So they're not trying, so first let's mark all the information that they gave us in the problem on this little model that they gave us. So we know that D and G are going to be equidistant from E. So that means equidistant means that they're going to be equal distance from E. So that means that DE, ED, and EG are going to be the same length. So these are going to be congruent. And then we know that, so that's like the first thing we got. And I'll just use this little tick mark for congruent. And next, it says that F is distinct from E, and that F is also equidistant from D and G. So that means with this line, these are going to be the same length as well. And now we have to find the measure of DEF and GEF. So DEF and GEF. So we can see here that we have split into two triangles with DEF and GEF. And we can also see that they have two of their sides are the same length, another 2 of their sides are the same length, and they share one side, so that side is going to be the same length. So since and that means that since all 3 sides are the same, that these two triangles are congruent. So that means that DEF and GEF are going to be equal because they're going to be corresponding. These angles are corresponding parts of a congruent triangle. So the answer is going to be